All right, hello guys. All right, so if you check out the screen here, this video is going to go along with water notes. So if I go back to classroom, under water unit resources should be your water unit notes packet. And if we scroll down, this is the second section of notes. So you should have the water resources completed. And then starting on page 3 is looking at water quality and water pollution. So that's where we are. And okay, so taking a look at water quality and pollution, some of this stuff is going to seem like kind of obvious. But a lot of these things, I think most people, including like your parents, have never actually thought about. So let's get started. When we look at water pollution, we actually categorize it into two main groups. So there's one that we call point source. So this is pollution coming from distinct locations that enter the waterway from like one area. So if you look at the pictures here, you can see these are examples of a point source pollution where the pollution is literally just coming from one point. So one factory or one, this here on the left actually looks like storm drains to me. So even here in Kettering, Ohio, under our streets, we have what we call storm drains. And it collects, when we have a rain event, it collects water. And you can imagine though, all that water that's just like running down our streets before it makes it into the sewer, it's collecting lots of junk, right? Lots of chemicals, oil, gas, physical trash. And the sewer pipes drain somewhere, and it's different depending on the city that you live in. Ours goes directly into a river, which is why if you've noticed in Kettering along the streets on the storage, the storm drains themselves, a lot of them now have this, well, like the last 10 years, they've added a little logo that has like a little fish or something. That's just representing the fact that anything that goes in there is not filtered. It goes directly in, dumps directly into a waterway. Again, some cities actually send that to like a wastewater treatment plant, and it does become treated, but not here in Kettering. Okay, anyway, so point sources. And then non-point sources are types of pollution where, you know, we call it like diffuse areas, such as a huge area of farming, right, that pollutes the waterway. So farmers just in general covering their fields with chemical fertilizers, pesticides, and herbicides. The same thing is happening here in the back, you know, on our lawns here in Kettering, Ohio. So when we look at the images here, one of them, this to the left, is representing a point source because it's one, you know, one point that's dumping into a waterway. And then on the right side here, I'm going to call this livestock a non-point source because so their poop, although yes, we could say it is like naturally occurring, but it's, you know, the animals that live in this river right here, they're not adapted to live in a, you know, in a river that is totally flooded with cow poop constantly. So we have to keep in perspective with things like horse poop that seems totally normal and natural. I mean, cow poop, sorry. That although, yes, like a natural organism is producing it, but it is not meant to be, you know, dumped into waterways in such high quantities, for example. So I'm going to call this on the top, or sorry, on the bottom right, a non-point source because there's just little tiny pockets of cow poop plopped like over a large region, for example. When we look at the categories of water pollution, we kind of break it into 5 groups. So let's first look at nutrient pollution. So nutrient pollution is too many nutrients that enter the waterways, which creates environmental hazards. So it seems crazy that actually one of the leading causes of pollution is too many nutrients, but it's true. Again, even though, you know, organisms need nutrients, too many nutrients causes a huge variety of problems. So remember that fertilizers are just doses of nutrients, right? So when your parents fertilize their lawns, or when farmers fertilize their 500 acres of corn, and they're trying to help the crops or our lawns grow, those are just nutrients. And most of those nutrients honestly don't get absorbed by the grass in your front yard, or don't get absorbed by the corn in that field, and they run off into other areas. So the biggest problem there is just over fertilization. So I've seen like demos of making homeowners grab a bag of fertilizer from Lowe's, read the package, and try to come up with actually how much fertilizer to apply. And it's like a small fraction of what they normally apply. So homeowners oftentimes get a bad reputation because they, a lot of scientists say that homeowners just over fertilize, and we douse our yards with even like chemical herbicides to kill weeds constantly throughout the spring, summer, and fall. So the extra nutrients, when we have a water or a rain event, what isn't already absorbed into the plants oftentimes either saturates down into the groundwater or runs off into the local, like the ditch that makes its way into the creeks, streams, rivers, lakes. And that is what we call runoff. So runoff is just basically extra nutrients that makes its way into the waterway. A buildup of these extra nutrients oftentimes cause what we call an algal bloom. So algal is like a huge growth of algae, right? So because the algae are living in just this buffet of nutrients, they just continue to grow and grow out of control. The algal bloom can kill off aquatic organisms such as fish, shellfish, really anything in that waterway can be harmed or just killed because of algal blooms. And the biggest problem here, if you look at the picture here, this is a floating mass of algae. You can imagine that sunlight is not making its way through there, right? So normally aquatic plants live under the surface of the water, and they get sunlight throughout the day as needed, and they photosynthesize. They are being shaded out. So oftentimes they die. So the aquatic plants that live under there die. All that dead stuff, and frankly, the dead algae as it slowly dies, creates a huge amount of decomposition, which feeds on tons of bacteria, right? So just breeds bacteria, all those dead plants, the dead organisms, the dead algae. And lastly, because now the aquatic plants that were supposed to be there have died off, they've been shaded up and die off. Now they're not producing oxygen. And so, most of the organisms that live in aquatic ecosystems absorb oxygen from the water, right? Like a fish. And now that water concentration has decreased drastically because the plants aren't there to photosynthesize. So here's an example of agricultural runoff in the Gulf of Mexico. So the Gulf of one of the big rivers that dumps into the Gulf is the Mississippi River. And if you remember from the last lecture, how massive the Mississippi watershed is, like multiple states eventually dump into the Mississippi. All the states that have all the agriculture, for example, just fill the watershed with all these extra nutrients and eventually dump the nutrients into the Gulf. This is what we call a dead zone. So it's very typical in like the same regions every summer that we get what's called a dead zone in areas like the Gulf of Mexico, because there's so many nutrients, algal blooms just grow out of control and then literally kill organisms in that area. Okay, so solutions to reduce eutrophication. Eutrophication is really just like over nutrients, an overabundance of nutrients. One thing we can do is use detergents that don't have phosphates. So phosphate is an example of a nutrient that's oftentimes present in fertilizers and like detergents. So your shampoo, like cheap, most often it's like cheap shampoo, dishwashing detergent, clothes washing detergents, dish soap, just like what you might use at your sink, for example. A lot of times the cheap ones will contain phosphates and they make their way into the waterways. One thing that farmers are getting better and better at is actually planting vegetation around their fields. So if they have a 200 plot of corn, they're actually planting kind of what we call a buffer zone. So a buffer zone wrapping around the field of plants, and those plants are intended to kind of soak up any extra nutrients before the runoff is able to run, like literally run off into the ditch or the stream or the river or whatever. Another thing is to just get better at treating wastewater. So for example, we could gather the storm water here in Kettering that we don't currently filter. We could actually treat the storm water. And then reduce fertilizer application. So there's a massive movement in the last 5 or 10 years to educate farmers on how much fertilizer they're applying. I've actually been to 2 conferences in the past year, really, aiming towards educating farmers. Farmers are really smart. They work unbelievably hard, but a lot of them honestly are like what they've learned as far as fertilizer application just kind of gets passed on to them from the community members, from family members. And so there's a big push now to get a little bit more educated with what's appropriate for fertilizer application. Okay, the second type of pollution is toxic chemical pollution. So this is probably one thing that, would always come to your mind. So we're thinking here pesticides, detergents, heavy metals that make their way into the water. Most of these are released from industrial or manufacturing processes. They can obviously be extremely harmful to humans if we're exposed to it, plants, animals. There's lots of examples where we believe that industries releasing some type of material into the waterway have caused a number of diseases, including cancer. So our government does try to do a really good job of monitoring and controlling the amount of these substances, but unfortunately, a lot of them kind of go unnoticed, if you will. I just think this is so interesting. So this is from 2012, but really in the sense of this, I mean, it's probably not very outdated, really. So pharmaceuticals and which are medications, and hormones found in water. So if you look here with the frequency of detection, so steroids are oftentimes, like 90% of the time, present in water. Steroids. So steroid, like if you've ever been put on steroids because you have, some type of little infection or something, it's just a really commonly prescribed medication is a steroid. Non-prescription drugs. So we're kind of clumping over-the-counter meds. So like, acetaminophen, Tylenol, ibuprofen, things like that. Antibiotics are present in about half the water samples that were tested. Again, that's something that would be prescribed if you have like an ear infection. Reproductive hormones found in 40% of the water samples. I would say, if anything, if these have changed in any way, that might have gone up. So that's basically birth control, right? So females that are taking birth control, they take most often the types of birth control are that you take a pill every day. The body absorbs the hormones that it needs, but also pees out a whole bunch of extra. And so we're seeing reproductive hormones, human reproductive hormones present in water samples. And then other prescription drugs is about, a little over 30. The third type is just solid waste pollution, so trash, right? So this includes garbage, sludge from treatment centers and industrial processes, stuff. So one thing is this just massive floating garbage patch. So it's called this one in particular, which I believe is still the largest in the world. Now there's lots of these floating masses of garbage, but this is the North Pacific Gyri Great Pacific Garbage Patch. So it's basically here in the Pacific Ocean. It's this massive, massive collection of trash that's just floating. And it's just getting bigger because no one's claiming responsibility. So if you look on the map here, I mean, it doesn't technically belong to anyone, so no one's doing anything about it. It's really disturbing. And again, as I said, now I've lost count of how many garbage patches they've identified, but there's lots, and you can see how massive it is. Look at the size of it compared to the United States, right? That's how huge this floating mass of trash is. One example of the problems we're seeing with it is the top right here. That's a bird called an albatross, which spends almost its entire life in the water. The only time it comes out of the water is during the breeding season, actually when the females when they build a nest and lay eggs. And they go to the same islands that their family's been going through for generations. They go to the islands, and so scientists hop to these islands with just full of albatrosses laying their eggs and raising their young, and they see pictures like this on the top left. So here you can see an albatross has died, its body is decomposed, and you can see what's left behind. So we have some bones, we have some feathers, and look at the pile of trash that was in its stomach. So we see lots of organisms that we believe their population is drastically declining, and we can tie it back to literally just garbage in wherever they live, for this example, in the ocean. So the top 10 trash found in the world's ocean, number 1 is cigarettes, disgusting. Cigarettes. Number 2 is food wrappers or containers. Number 3 is plastic beverage bottles. Number 4, plastic bags. I think they give me the willies. 5, lids or caps. 6 is cups, plates, and cutlery. 7 is straws. 8 is glass beverage bottles. 9 is beverage cans, so probably aluminum there. And then 10, paper bags. So plastics are harmful in their own unique way. So plastics can release harmful chemicals into the water once they're broken down. The UV light breaks them down, which causes them to release harmful chemicals. And also they're physically getting broken down into extremely tiny, tiny, tiny little pieces and are being mistaken for food. So a lot of organisms they have little tiny bellies full of plastic, like even little tiny, I mean, there's tons of articles on this. I become obsessed with it. Tiny little pieces of plastic found in their bellies. Okay. The fourth type of pollution is thermal pollution. So literally just heating water. Again, yes, we know that heat in a sense is natural, but not in these regions. So a lot of the water that we use in industry is used for cooling some type of industrial process or equipment. So if you look at the example here on the top left, here we have some type of industry intentionally built right along this waterway because it wants to use it as a water source. And so far, this is totally legal. So you can see right here, this factory, let's call it, is sucking up nice cool water, and it's using it in the machinery. And honestly, most of the time, it doesn't even absorb chemicals. It's just literally cooling material, and then it gets spit out down here a little bit downriver. But because it was used to cool like unbelievably hot equipment, it's extremely warm or hot when it is spit back out into the river. So we call that thermal pollution because it has drastically changed and increased the water temperature of that waterway. Again, although it seems natural in some regions, it is definitely not in these regions. So it kills off, plants can't live there, organisms can't live there, the fish can't live there, and so they die. So because it's causing, ecological nightmares, it is considered to be a type of pollution. So the negative effects of this is increased water temperatures affect the digestive rates of organisms, the heart rates of them, the respiration rates. Warmer water holds less oxygen. So most of the time they actually suffocate because there's not enough oxygen in the water. So lots of things that happen with thermal pollution. The fifth type is, sorry, I have a timer going over here. If I could get my phone. Okay. The fifth type is what we call biological pollution. So bio means living. So biological pollution is typically what we refer to as like bacteria, viruses, right? So when disease-causing organisms and viruses, which we call pathogens. So a pathogen is anything living that causes diseases, make their way into waterways. So drinking supplies become contaminated when exposed to animal or human waste. So once water has been introduced to, this bacteria or virus, it becomes a major health problem. Now, it kind of seems crazy to us. Again, our drinking water here we're just so lucky. However, if you've ever heard of like the recall of lettuces, for example, or spinach, that is biological pollution. So that's usually E. coli, which is bacteria that has been sprayed onto the crops and then gets shipped throughout our Kroger. So when lettuce is recalled, it has literally been sprayed with water that was contaminated. Usually it's E. coli. And it's probably contaminated from literally a farm, a livestock farm, a cow farm upriver, honestly. So the most direct contact we have with biological pollution is food recalls, but you have to then think bigger picture, how many people globally struggle with access to safe, clean drinking water. So if we look at the examples here, I already mentioned E. coli, that's a bacteria we know that causes makes us very sick. Cholera is the same, typhoid fever, dysentery. So millions of people die across the world every year because of biological pollution. So basically becoming so sick that it kills them from something living in their water. Over 1 billion people lack access to safe drinking water, and over 2.5 billion people do not have access to adequate sanitation services. So now we're looking at where do people go to the bathroom? And these billions of people are oftentimes using their drinking water to also go to the bathroom with. One contributor to this is just education. They don't know. And some of these pictures here, look at these pictures, you guys. So this is literally their drinking water, and they also just go to the bathroom in it. So look at the top left picture. This is an outhouse. They're going to the bathroom there. They poop there, they pee there. And then look at the individuals bathing here, maybe even just cooling off, but they're swimming there. In many places, they go downstream and fill their drinking water jugs, guys. Okay. It's just heartbreaking. So again, here we go. To put in perspective, remember globally, people like every single day, they walk to access drinking water and they haul it back for their use. Here are just some common examples of what we would call bathrooms around the world. These examples, you kind of like walk up to them and stand there and you pee or poop. What it looks like underground is often, and this is actually pretty, pretty advanced, really. So someone goes to the bathroom, and then there's a little channel that diverts it back into this tank. The problem is these tanks sometimes are literally like, they're not lined at all. So it's just like a big pit underground where human waste is directed. So it's better than going directly in the waterway, but oftentimes it just seeps into the groundwater anyways, right? So here's kind of an example of that, where we have it, it's honestly, it seems like pretty advanced because they've built these structures, but they don't understand the concept of groundwater. So here we have human feces that are just draining directly into the groundwater and then contaminating the drinking water downstream, where they are filling up their pails of drinking water. So remember, just plain old dirty water, biological pollution literally kills lots of people every single year. Oh, I forgot in the past, I found a funny little video, but basically there's also a movement, of trying to utilize human feces. So what we're seeing here are human waste briquettes. So basically they collect human waste, they sanitize it through UV rays. So they lay it out in the sun, they dry it really, 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 really well. So it essentially feels kind of like charcoal, and then they burn it. So here they're burning it in the bottom right picture. They're burning it for heat, for cooking. Okay, so what are some of the solutions for this? So number one, is waste treatment. So we have a massive infrastructure designed to deal with water. Most of it here in Kettering, Ohio is under our roads, like I said. So we have storm drains that carry water from rain events, but we also have, these big, huge pipes that carry water from your house to the wastewater treatment plant. So ours goes to a treatment plant. Yeah, so ours, sorry, if you look here on the bottom left, this is the combined sewer. I think I mentioned, so some regions actually do have, where their household wastewater and the storm drains dump into the same pipe, and they all are treated equally, like at the treatment plant. But ours is separated here in Kettering. So we have one pipe in the street by your house. There is one pipe that's taking, used water, in the yellow, the used water from your house, and that's taking it to our water treatment plant. And then we have another pipe that's just storm drains. And you can see here that goes directly into a waterway. And ours is that case. So ours goes directly into the waterway. Okay, sorry. So when we think of treating water, like what happens after we use water? One option, which is not the case for Kettering, this is for rural areas, but I'm talking like some people in Beaver Creek may have this. Definitely Bellbrook, Sugar Creek would have septic systems. So typically areas that are further from, like urban areas. So septic systems are a large container that receives the wastewater from the house and processes it. So if you look at the image here, you can see all the wastewater from the house gets dumped into this tank. This tank is something that you would pay, I don't know, a number of thousands of dollars to have installed in your yard somewhere surrounding your house. It gets buried, and the waste in there, it's just the septic tank is full of good bacteria that break down all of that waste. So that's how it functions, is by good bacteria. In fact, the bacteria is how it works. So people with septic systems are not, for example, are not supposed to use like antibacterial hand soap, antibacterial sprays, because antibacteria products kill the bacteria in a healthy, functioning septic tank. So what we want in a septic tank is a buildup of this good bacteria. And it typically processes like most of the waste. Anything solid that doesn't get broken down falls to the bottom. So you can see the like black buildup here. That's just the solid from the solid waste that never gets broken down. What floats to the top is essentially like the clean water. So that gets then piped through what we call the leach field or the drain field. And this is also, so this was, something that was installed initially as well. And it basically like pipes water underground and like picture pipes coiled. And basically it just disperses the water underground. So it will be released and then filtered through, like the soil or the rocks or whatever. And so that's a septic tank. The only thing I'll say for maintenance here is a healthy septic tank will, periodically, depending on the size of the family, but periodically this sludge at the bottom will get sucked out. So there's usually like an access pipe, and you call the company and you say that you need your sludge sucked. And so they'll bring a big old truck and just put a pipe into the hole and suck up all that sludge. And then usually it's good to go. Wastewater treatment plants are where our water waste goes. So it's a centralized plant in areas with, larger populations. They treat waste from homes and businesses. They are gathered and then basically like sent to the waste treatment plant. It uses the force of gravity, which I think is cool. Ours, because it uses gravity, goes down to moraine. It includes 3 major steps in the process, how they treat it. And eventually our water here from your home or from Fairmont actually sent down to moraine. It's treated in the wastewater treatment plant, and then it is just released into the river actually down there. So here we have the primary treatment. Wait, sorry. Okay, let's start with number 1. So number 1, our water is piped underground. Number 2, the large debris are filtered out. And by large debris, when I'm there, I mean, I saw the screen for this, and it's like literally basketballs and like shoes, right? Like big stuff. And of course, toilet paper and stuff. Some of that gets caught here too. So as it comes into the treatment plant, there's a filter filtering large stuff. The solid waste also here, similar to what we saw in the septic tank, falls to the bottom and it gets sludge. It's called sludge, and it gets basically shipped away. And actually, we'll talk about that in a sec. So the water here after the primary treatment gets sent to the secondary. Here in the secondary treatment, we're also using a really massive population of bacteria that are going to break it down. From there, it gets moved on to the first, like in this whole process, the only dose of chemicals. So we will use UV light, or our treatment plant uses chlorine, like a low dose of chlorine to kill any pathogens. And then ours is released into a local river. If we go back to all the sludge, so along the way, all of the like solid stuff that falls to the bottom, if you notice, it gets, in this image, it's getting shipped away. What actually happens at our wastewater treatment plants in the area here is it actually goes to what they call on-site is called a kiln, like a pottery kiln, and it dries the sludge so that it becomes like a powder, like, right? It sucks all the water out of it. And then they actually give it to farmers for free to use in the area as fertilizer, right? So it's just poop that's been turned into fertilizer. Some other regions actually will sell it, But here, as far as what I've heard from my tours, they actually just give it away to the farmers, and they're happy to not have to pay to do anything with it. Okay. Another option is to compost our own poop. So there are composting toilets on the right side here. You can see a picture of the composting toilet, and it literally just slowly composts the waste. There is some maintenance depending on how many people are using the toilet and how often they use the toilet. But I know people that have had them and love them. On the farm when I lived in the teepee for a number of months, like 8 months, we just had what looks, literally what you see here, we pooped and peed in a 5-gallon bucket. Every time you went to the bathroom, you dumped a scoop of wood chips on the poop or pee, and it absorbed scent. So honestly, it didn't smell. And when the bucket got full, you were just in charge of taking the bucket, and there was a area called the human manure compost pile, and it was just all of the poop and pee, and what you really saw was just a pile of the wood chips. But it really wasn't that gross. It didn't stink, and it was just like a functioning composting pile with human pee and poop. Then when we think of drinking water treatment, so on the other end, like what happens to make our drinking water drinkable? So as we kind of mentioned already, the EPA is the one that sets the standards. All water suppliers must meet those EPA regulations unless you have a well on your property. So people, again, not far from here in rural areas may drink their water from their own well, like sucking it up from their property, and they are responsible for monitoring their own water, right? So it's like an independent system. They suck up their own water, they regulate it if they want to. Processing drinking water. Oh, let me point out that the EPA is in charge of this because it has to be essentially clean enough or safe enough for farmers, right? So you imagine a farmer would tap into for example, or even just us. Let's just think about your parents. So your parents, the water has to be safe enough and clean enough to dump into the environment when they're watering their lawns, right? So I mentioned that our water is treated with chlorine. There's a big chlorine dilemma. So people don't want to use chlorine because even small amounts of chlorine have been tied to certain types of cancer, miscarriages, and even birth defects. And then the other thing that's added to our drinking water intentionally for drinking is fluoride. So back, I believe in like the 60s and 70s, tooth decay was a huge problem. And as we became more and more aware of what was causing tooth decay, we also became more aware of what hinders tooth decay. And one of the major things is fluoride. So like your dentist, I think periodically may do what we call a fluoride treatment. So back then we had this strike of genius to just add a little fluorine to drinking water. And still to this day, most municipalities add fluoride to drinking water. So our drinking water here in Kettering, Ohio, as far as I understand, actually does have a low dose of fluoride, and it's literally just to prevent tooth decay. However, even low doses of fluoride, again, have been linked to particular cancer and kidney disease. So there's also now a push to end the fluoride. People are saying, like, most people have access to, toothpaste now, mouthwash. They go to the dentist regularly. We don't have to now make everyone drink this fluoride in our water just to try to prevent a little tooth decay here and there. Another thing that happens is there's lots of government regulations when it comes to water in general. The Clean Water Act was put in place in early 70s, so in 1972, and it is still in place, and it is the single most important law to prevent water pollution. So basically, the Clean Water Act is what makes it illegal for big, huge factories to just dump massive amounts of waste into waterways. It also sets the standards for pollution levels on like surface water or industrial wastewater. It is what funded the construction of sewage treatment plants to begin with. So again, the Clean Water Act is an example of, a piece of legislation that was put into place, and oh my heavens, has it made a tremendous difference. And that's, across the entire country. Other examples of water laws are the Safe Drinking Water Act. So it just enforces the regulations that must be met for drinking water. So an example of like a feel-good story after like water has gotten really disgustingly polluted, and then thanks to legislation being put into place, we see a huge difference. So the Great Lakes, you can see the picture of the Great Lakes there. Of course, we know that Lake Erie is our northern border here in Ohio. So that's our local Great Lakes. So in the 70s, they were so unbelievably polluted, mostly from industry. This was before any regulation was put into place. And so industries used the Great Lakes for water to cool their equipment, and the waterways to ship on huge barges lots of the things they needed and then the things they were producing. So, and just dumping waste directly into the waterways. There's tons of Google images all over the internet of signs all over the Great Lakes saying it is not safe to swim. So they became literally so polluted that you were not supposed to swim in the Great Lakes. Many of the waterways caught on fire. So this is the Cuyahoga River, which is up in Cleveland. It dumps into the Lake Erie. Literally has caught on fire, I think, actually multiple times. The Ohio River's caught on fire. Literally the rivers were so polluted, they caught on fire. So these are pictures of like the most destructive fire in the Cuyahoga River from 1969. So this is just to put in perspective, like how bad it got until we did anything. Since then, so since the Clean Water Act, which was, again, remember in 72, we have seen it works, right? So it works. And I think that's what people fail to understand is like the environmental legislation that's put into place in any of them have been put in place because things got so bad at some point. Now, most of you probably never knew that waterways ever caught on fire. So it would be easy for you to vote for, a political figure that's saying, we need to let industry use water. How polluted could a Great Lake get? Because we are so disconnected. We've never seen a world where the rivers are catching on fire, and it's because of the environmental legislation. So I feel like what I see when I'm watching politics nowadays is it's like it's almost like an ebb and a flow, right? So it's like if you look back in the 50s and the 60s and how unbelievably polluted areas become, it was so disgusting that we had to then start enforcing things. And now it's almost like we forget what it ever looked like or how bad it ever got in so many of the cases, which is why I think people are trying to people feel comfortable becoming slack with environmental regulations. So anyways, the Great Lakes, it worked. So the legislation, the Great Lakes now they're still polluted and they still have their challenges, but it has shown tremendous improvement, which has obviously helped the plant and animal population there. Okay, I think that is it. So you guys should now have finished the second portion of the notes.